Okay, so um,
What happened? We were outside for like 5 seconds.
allergy.
Let's do.
All right, so we're gonna go to improper integral.
Using.
Okay. Sorry. Quick time. So improper integral is tested on BC exam. Is one of the things that you will test it. So let's kind of recap everything. That first of all, we talk about integral technique. Now, integral technique, you got split, you got conjugate, you got uh, long division, you got multiply by conjugate, you got all different kind of things. Those are part of the tools. Use Pythagorean identity. Those are typical things. 8.2. Let's go back to 8.2. 8.2, we talk about integration by parts. So on your next test, Thursday, integration by parts. This is on your test. You got a DI method, when to stop, and you got, sometimes you got a secant cube of x that is different. You got integration of natural log of x, integration of arc sine of x. All those things are integration by parts, even cyclic and all kind of stuff that you can think of. So that is the 8.2. 8.3 is trig integral. So what is trig integral? Oh, yeah, that's right. Something's allergy, something. Trig integral, which is like integration of, like, say, sine square of x dx. Is something. Sine to the 7 of x cosine of, like, 4 to the x dx. So you have some type of trig integral like this, even like power reducing, using Pythagorean identity, and use different things. And then trig substitution, trig sub. So it has like a squared plus x squared, a squared plus u squared, a squared minus u squared minus a squared, three separate cases. That's gonna be also on the integration. But this one is not on AP exam. So this is not on AP exam. But this is yes. This is yes, it's halfway. Power reducing, yes. But this is no. Okay? Now after trig sub, we already talked about partial fraction. Partial fraction is yes. You always have to break up for different reason, not necessarily integral, could be on sequence and series. So on sequence series, you might have to break up to two pieces for, like, sometimes for telescope series and for different things. So you might use partial fraction. So this technique is something that you needed for different reasons. So yes. Now the last one is yes, is improper integral. So we're going to talk about improper integral today. Very easy.
Can you post it now?
Yeah, as soon as I finish. You should, because you're gonna see it on the test.
You do that. Well, I can't do it. I can't do it either. I'm faking. What? Like it's not the right way. It works. Oh yeah.
All right, so integration of a to the infinity f of x dx. So when it reaches infinity, you have to rewrite it correctly, which is you have to say b approach to infinity between a to b of f of x dx. Just like AP exam, they want you to write it this way, just like El Hapto rule. Of course, you can plug in infinity in there and you can evaluate it, but very importantly, you have to understand that there was a things like that. So this is a definition of improper integral. With indefinite integration limits.
It's the practical application of an integration to infinity.
I remember I asked this, not for like 1 over x, but like something that like,
1 over x doesn't work.
but you know like the idea though, right?
Yeah, but 1 over x to the 1.1 worked.
Really?
1 over x to the 1.2 works, but 1 over x doesn't work. It would diverge.
Like when there's asymptotes.
1 over x squared is called Gabriel's horn. I don't know. You saw it on math competition question. They would say Gabriel's horn. That's like, it's like 1 over x squared to infinity, from 1 to infinity. So that's the first situation. Second situation, you can have negative infinity to b of f of x. You can have the other way. And that's just going to be limit b a approach infinity of b to a and f of x dx.
A approaches negative infinity.
Yeah. You can have the left side to the thing.
Which one is this called? Or what is this one called?
This is also improper integral. All those are improper integral.
With indefinite integral limit. So
Mhm. Now you're gonna have the last one, which is negative infinity to infinity of f of x dx is equal to negative infinity to c of f of x dx plus from c to infinity of f of x dx. So you can break up the two part. If you have infinity to negative infinity, you can actually technically break it up.
Can you do that with like other problems?
We're gonna do that without a problem.
No, but like normal problems. Like if you have like integral from like 2 to 5, and you have integral from 2 to 4 plus integral from 4 to 5.
That's just a
Is it?
basic identities. Yeah, you can definitely do that. That's just one of the integral. It's called additional property for integrals. But the first one, I'm gonna get 1 to infinity dx over x. So this one is very well known, and you have to understand there was a difference between this one and the x to the 1.1. 1 over x. If you take integrate of this, it's going to be natural log of, actually it's going to be, sorry, I'm going to rewrite it, 1 to b limits as b approach to infinity of dx over x, which is left with the natural log of x between b to 1, limit b approach infinity. And that's going to be natural log of b minus natural log of 1 when limit b approach infinity. What's natural log of infinite? Good. And minus natural log of 1 is going to be 0. So it's going to be infinite. In this case, it's diverge. Why is diverge? If you have a graph of 1 over x, 1 over x like this. Even though it's gonna be here, but the thing is opening is way too y for you to converge into one value. But if you have 1 over x to the 1.01, it's gonna be converge. Because you no longer have a natural log, you have something else. So if you have natural log of b, that's automatically um, diverge.
Let me ask, so, like, we can say like it never really hits. So, okay, but if you do limit as x approaches infinity of 1 over x, you plug in infinity, you get 1 over infinity is 0. So once you say at infinity, it touches 0? Do you understand 1 over x would touch 0 at infinity? So wouldn't there be a defined?
No, it's not. Because the rate is going, it's still gonna increase slowly, but it's slowly, but it's too fast for them to converge into a value. Because you are talking about area under the curve, it's something that is slowly, eventually it's gonna go to this, but it's still increasing constantly. It's not plateau in the value. So for example, let's say if you got, like, it doesn't work if you have, that's a good question though. Is my eyes flip over? Is that Reebok's laughing?
Why? Oh.
How do you know that?
Because Reebok's laughing. Why don't you just say something, you jackass?
That's like, man, if you think about it though, like, because I just did it limit as x approaches infinity.
No, let's think about this, right? That's a good question. So if you have 1 plus 1/2 plus 1/3 plus 1/4 plus
Yeah.
1/5 like this,
Oh, that's equal. That's 2. What's equals?
no.
Oh no, is it
Infinity.
2? Oh, that one is 1/2 plus 1/4. That's that. That's that.
So this one is different though. So 1 over, let's say 1 over 2 plus 1 over 4 plus
that's
1
right.
over 8 plus 1 over 16. This one will eventually converge because we know if we take one pizza and we take a half a pizza and we take a quarter pizza, we take a 1/8 pizza and 1/16 pizza, this is going to be converge. But this one is not conversion because it still gets larger. Do you see that?
That makes sense. That's a good example. Yeah, because
What's the top one?
Well, we don't know. That's why we needed to go into sequence series to figure out it is. But it's gonna be diverge because it's gonna be more than the 2 pizza, and the next one is gonna keep on growing, still keep on growing. It doesn't matter what it is, it's always growing.
okay.
But this one has a plateau.
Yeah.
So this one, 1 over x is actually the boundary line between converge and diverge because 1 over x is definitely diverge. But 1 over x to the 1.01 is definitely converge.
Interesting.
So exactly a line 1 over x is diverge for sure.
Yeah.
Because there's the other formula we're going to introduce to you, and it's going to affect in the power series. And that's going to say, oh, that makes a lot of sense. But this one is diverge. And so I want you to try a couple problems. One is infinity e to the negative x dx. And Anthony already tried this one already. From 0 to infinity of 1 over 1 x squared plus 1 dx. That's the question that we did the other day in math competition. And there's the improper integrals. Yeah, you should have been here.
Anytime.
Yeah, you can come. Every time you say come, you're not coming.
Yeah. Okay. I'm gonna put my tutor. Wait, yeah, you go. Have they paid yet or no?
Yeah, you pay. I just pay me just
Okay,
now.
so they're still okay. I was like, did they just completely get to the 8 already?
No,
I'll text them again. That's good then.
it's annoying. I hate those people that just change. But not like I can do anything because that's their right, I guess. But at least they should have told you earlier. Dude, you're not showing up? Don't show up. That's fine. Let me know earlier. It's okay. That's why usually I get mad at them and I start yelling at them. Yeah, I'll be like, okay, dude, either yes or no. But there was one guy is in like First Academy, make an appointment with me like 3 times, and I was like, we're gonna show up, never show. It's very annoying. This is on AP exam.
Would we get
Yes,
so we would have to write out
limits.
Oh, interesting.
I swear we did this. Like, is it a dream thing?
For the second one, yeah. You're not crazy.
He yelled at you guys yesterday. I forgot what was that.
I still don't know it. I know it's a true thing.
I yell at who?
It came with it.
Well, not yelling.
I think it's
No, I was. I would never yell.
No, it wasn't.
Do you know how to do
I
it?
don't yell.
I think it's just Arctin. Or something.
Arctan? Just Arctan?
Yeah, Arctin.
Because that's an integral. That's the one that you're supposed to know.
Is the first one negative e to the negative infinity?
What's e to the negative infinity?
Oh,
What's Arctan? It's
It'll be 0.
oh,
0 minus
Okay, so
type
this first one, I'm gonna say b approach to infinity of b to the 0. Make sure you write down limits for you to get whole credit on AP exam. So therefore, it's gonna be now if it's a regular MCQ, you can just treat it as infinity and just do it inside your ad. It's actually fairly easy, but you want to get the point as much as possible to get improper integral points. So that's going to be negative e to the negative x from b to 0 limits of b approach infinity. And that will be limits b approach to infinity of negative e to the negative b minus e to the 0. What's e to the negative b, which is negative infinity? That is equal to 0, negative, negative 1. That's going to be positive 1. So the answer is 1 here.
What? What?
because 1 over infinity.
No, I get that, but
E to the 0 is
no,
1.
how is it positive?
Because in the front, there's a negative sign when you integrate the e to the negative x.
Yeah.
And that negative sign's out there, and it's going to distribute inside, so that negative times a negative become positive.
Oh, okay. I see.
And again, you can look at a graph of e to the negative x. So e to the negative x. So this is, see that Daniel, you see that graph? It's going down way faster
I see now.
compared to 1 over x.
It hits 0 like right away.
Yeah, compared to 1 over x, see that? You see that 1 over x is this just still getting bigger as I'm going up. Long as it gets small enough big, it's still increasing. It doesn't matter. So there was a rate of change. It happened is like how fast you're growing, right? But you see this one is really defined. This one's way less. So I always told students to knowing this graph, because anything within that graph is gonna be converge. Anything outside of that graph is gonna diverge. Okay, so 1 over square root x. So look at 1 over square root x. Is it diverge?
I'm gonna say no.
Diverge or converge here?
Yeah. I mean,
Look at it.
is
The green line is already diverge.
divergent. There's no value. Right?
diverge is not a defined value. It's gonna go infinite.
So I'm gonna say, yeah, not defined.
Yeah, so
That's
the
right.
purple line is way over that.
Yeah.
Now, if you have 1 over x to the 1.01, right? Hopefully they can see the difference between that line, but you see that line is barely below
It works.
and not work.
That's crazy.
So 1 over x does not work, but 1 over x to the 1.01 works.
So you said that that's the key, like
That's like a boundary of where it does not work. All the way to that point does not work. After that, it works.
Well, 0.99.
0.99 does not work
Oh.
because 0.99 is gonna be less than 1 over x. It's actually pretty interesting. I didn't understand it the 2 years before, and I was like, oh, okay, that kind of makes sense because that's a boundary. Anything before that or on that is gonna be diverge. Anything after that is gonna be converge. Okay. So hopefully you understand that part. Now the next part is gonna be. No, those are good questions. Those are good questions. So the next one is this one. So it's gonna be limits as b approach to infinity of b and 0, and this is 1 over x squared plus 1 dx. So that's gonna be arc 10 of b minus arc 10 of 0 when limits b approach infinity. Now you have to understand one more thing. So on a side note, this one you have to understand the normal tangent graph. It looks like what? This is a tangent graph, y equal to 10 of x. It looks like this.
X cubed kind of.
And there is an asymptote, right? There was asymptote at pi over 2 and negative pi over 2. But turns out at this one, there is a inverse of 10. So it's arc 10. So there was a asymptote this way. And the graph's going to be like this. So I here, what is the asymptote? Pi over 2. Now what happened when we reach infinity? The 10 inverse. Sorry, this is the 10 inverse of b. So therefore, this is going to be, according to this, it's going toward pi over 2 minus 0. So the answer is going to be pi over 2.
Why is it inverse?
Huh?
Why is the arc 10 inverse?
Because integration, we talk about this, integration of 1 over x squared plus 1 is
I thought it was
arc
just
10. It's arc 10. Oh yeah, it's not inverse, arc 10. It's same thing. It's 10 inverse.
Okay.
I just double negative.
Okay, so then why is that one inverse? The one on the right, the graph. On the right is
The arc 10 graph. Arc 10 is the 10 inverse. So arc 10 is x equal to 10 inverse of x. They are the same, another notation. So it go to infinite, that becomes pi over 2. Now let's check out this graph. Let's check out this boundary, right? Let's check out, I didn't get to talk about it last period, but this is interesting since you posed this question. So that's a red line. It's way below the boundary line. It's good. It's defined. Anything above that line is what not defined.
That's really
It's pretty crazy.
Oh, is that why you can't integrate 1 over x?
You can integrate 1 over
I mean,
x.
you can't take the.
You just cannot take a definite integral from 1 to infinite because the area is way too large. It's gonna keep on accumulate more. It's not gonna converge into a value. So that is exactly lines cannot it's diverge. Anything below that line, it will converge. Longer, see, they both have the same asymptote. See, this one is going to go down way fast. There's not enough increase for you to overcome that. Very interesting question. Does that make sense?
So you can say because it's so slow, it accumulates so much area that you just say it's infinite.
Yeah, but that's the cutoff line.
Yeah. 1/x. That's why.
Yeah, 1/x.
because
So
it's-
later on, we're gonna learn something called limit comparison test, and it's very similar idea like this. You just convert. You cannot convert. You cannot really compare 1/x to 1/1 plus x squared, but you can compare to 1/x squared, because 1/x squared is converged. Then you can say, oh yeah, because due to direct comparison or limit comparison test, and you can actually say it's converge or diverge. This is a very interesting. This is just the beginning stage. That's why this lesson's really important. It's really easy, but it's really easy, important building block for your sequence and series lessons.
Wait, can you go up really quick?
Yeah.
Okay.
Okay, so integration from 1 to infinite of 1 minus x e to the negative x dx. Now this one's obviously is not a normal integral. So what kind of integral is this?
What do you mean? What kind?
What kind?
You do like the I method?
Good, DI method, because this is by part. And this is a 1 minus x. This is e to the negative x plus minus negative 1, negative e to the negative x. That's integrable. So that's going to be 1 minus x, negative e to the negative x, and 3 negative signs, so it's going to be negative e to the negative x dx. Now, I don't worry about the boundary at this moment. I just worry about taking integral because I'm going to plug in integral. I'm going to plug in integral later.
Wait, why can't you just combine the outside with the inside?
You can, but you're still going to have to deal with, you mean distributing?
Yeah.
Yeah, you can, but you still have to do a integration by parts because you're gonna still have a negative x e to the negative x regardless.
Okay.
You still have two different type of function. Regardless of that part, you still have to do that. So it's same thing. So I just do a di, which is not hard. So I am gonna integrate e to the negative x. That's gonna be plus e to the negative x. And this one I'm gonna distribute now, just like what Reebok said. Plus x e to the negative x. Now, if you see this, two gonna cancel out. So that'd be x e to the negative x plus c. Now, since we're doing the definite integral 1 to b limits b approach infinity of 1 minus x e to the negative x dx. Now we know at the end, we don't care. At the end, we just take the integral, but we know the result already. E to the negative x between b to 1, limit as a b approach infinity.
Wow.
Now you see here, it's probably better just move this e to the negative x on the bottom. Yes.
That's cool.
Yeah, so you kind of see it beforehand. B to 1, and I was going to show you in a little bit. It was L'Hopital rule because this one's going to be limit as a b approach infinity. If I plug in b, it's going to be b over e to the b minus 1 over e to the 1. Now, for this part here, and just like what Daniel says, he kind of foresee that, he kind of have that chess instinct. See that there's an L'Hopital rule here. Imagine that there's just convert b to x. That way you get to see it. X approach infinity of x over e to the x. This one's going to be infinity over infinity, which is L'Hopital rule. So I'm going to have to say limits x approach infinity of 1 over e to the x. So there'll be 1 over infinity, that's 0. So 0 minus 1 over e, the answer is negative 1 over e. Probably depends on the question. There's not a, I don't know. I hate when answer those questions without boundary. There's always situation that you have to do different things. So, but we have to see it because I don't know enough to tell you says which question that you have to do yourself. So, but if you see the question when the question involves, so we don't know that we have to use LHOP rule, but when the things come in play, that's a part of it. Then you have to use it. Like yesterday, you have a one question with long division. Don't know if you got to 11. Question 11 from the homework. Everybody's trying to do A, B, and A, B of the bottom. But the A and B is not enough to multiply to get extra third degrees on the top. So that particular case, you have to use long division. So every situation is kind of changed. That's why like integration B is kind of challenging for everybody because there's no one method that you can do it. Yes, U substitution is your tool. LHOP rule is your tool. Long division is your tool. Adding one, subtract one is your tool. Conjugate is your tool. Everything is your tool. As long as you're in your tool, then you can use it. I think yesterday, Charlie actually showed me a problem. If you do, hold on, Charlie showed me like, so Charlie says, hey, can I do this question this way? And that is fine. Let me see what question was that. I don't remember what question. Question 14. Question 14 was integration of 5x minus 2 over x minus 2 squared dx. Charlie, do you see what Charlie did? He didn't do partial partial fraction. For that question, he got DI method, and the answer would come out look completely different, and it was exactly same. It was exactly the integral because we graph it, and once we graph it, we saw. So you can try 14. So this is the question was interesting on your homework. 5x minus 2 over x minus 2 squared dx. If you were to do just normal DI method, this will give you a different result compared to the textbook answer. But we look up the result, we find out it's a vertical translations. So it's the C difference, that plus C. And to explain that C difference, yesterday somebody asked me, just for example, that's really easy. Let's say natural log of 2x, right? What's the derivative of natural log of 2x? What?
Over 2x.
Mm.
2 over
2 over 2x, so it's 1 over x, right? What's the derivative of natural log of x? How come they are the same? But if you pay attention to detail, natural log of 2x is equal to natural log of 2 plus natural log of x. If you take a derivative, that's just a part of C. So that if your answer is a vertical translation on the graph, it's fine. Even though it's different expression. Because depending on your initial value, what it's gonna be.
I think this was when I think I said like integral of there you go. The integral of 1 over 2. Yeah, integral of 1 over 2x.
Yeah.
That'd be the same. Or same like thing.
So in this case, you would be incorrect to say that out of the things.
No, it is. If you integration 1 over x, it's just gonna be natural log of x, right? But plus c, right? There's a c. They take account into natural log of 2.
And like when I said like integral of 1 over 2x, is you can like take out 1/2.
You can take out 1/2.
And then do 1/2 ln x. Or if you do u substitution, it would be 1/2 ln 2x, I want to say. If I think about it, maybe.
So that c is tell you the vertical translation depends on your initial condition. So that c is a general solution. That general solution you can shift up, shift down, doesn't really matter.
If you wanted to find a general solution, you can just.
Thanks for another great training day. Students, you are now dismissed.
One times out.
What do you mean?
Oh, it's not really hard.
Anyway,
Here's what I'm saying. Like, can we rule this? One over 2x is like equal.
I would say it's pretty cool though. This lesson's actually very interesting.
They just pay. Can you use substitution info? That's kind of weird.
Can I have a test actually?
Okay. Let me enter in the computer.
No, come on. I have literally three tests that I'm doing my questions for. So you know that. That's gonna change. You know, fine. It's okay. It's okay. Go ahead, do it.
Wow,
It's okay.
wow, this.
What's your complaining about?
I'm not paying
Wait,
attention.
they have
My
one-
mom tells me every day.
You want to?
Every day, my mom's like, "Oh, yeah, change."
Is it
Yeah, why don't you just change? Find it. I don't know what's there. I'm not looking for that thing. That's why I don't want to look for it. It was like I'm delaying because I don't want to look.
Did she ever respond? No.
I'm not looking
Yeah.
for it.
Well, I did run to take it. I had to go.
I saw it.
Did
I'm
not.
gonna ride home.
I thought you were. I played 8 ball.
We're going to practice. I'm not walking home.
That's it.